Everybody, this is Larry. This is day 5 of the December admin of code. Said that way awkwardly. Hit the like button and the subscribe button. Join me on Discord. Let me know what you think about today's day of code. We have about minute 40 to go. I'm very excited, and I'm going to switch to my my terminal where I actually do. This is how I just set it up, and yeah. Wish me good luck. I think at this point I'm just hoping for one day where I make the top 100. It seems the evidence abundantly more and more clear, and not just Larry being a sore loser. Maybe still Larry's being a sore loser anyway. Of the top, well, I want to say the top people, but I guess it's not really the top people, right? It's the top robots winning. The leaderboard is full of AI and stuff like this. So we'll see how things go. This is the first of those years. As I was saying on stream, I feel like, I mean, not that I'm anywhere as good as they are, but I feel like Gary Kasparov in like was it the Big Brew, the Deep Brew? Maybe I'm confusing things in chess, and just like okay, maybe this is it. Maybe this is the last year I care. I mean, and at least doing it like at midnight kind of thing, right? I don't know. Anyway, we do have about 18 seconds to go. I know it's hard to kind of see. I have the thing on terminals that you could see what's, unique to my thing, which is what I'm typing and not necessarily just what I'm looking at, which I'm mostly looking at the screen. So yeah. Anyway, 2 seconds to go, 1 second to go. Let's go. Okay, so we have a grid. Oh. Where's the starting? Oh, there's a thing. Okay. I couldn't find the starting thingy. It didn't really show. Okay. Let's see how do I want to do it. Oh wait, I'm typing too slowly. I mean, I guess I'm not a robot. Okay. Okay, and then now up, and then go right. And I'm too slow today. What am I doing? Okay. If I don't like the way I'm coding this, but maybe it's fine. $41, 4977. Too slow. 211. I feel like I'm always at about the same rank because the same amount of people cheat, I guess. Give or take. Alright. Finish. So that's not right. Maybe I misunderstand this one. No, it feels reasonable. Why only these? I mean, as soon as you're debugging, you're probably not making it. But I think my idea is right, but maybe not. Oh, I see. Actually, maybe not. I mean, it's kind of right, but it's not enough right. Okay, I see why, but yeah, I know how to do it, but it's just so annoying. Okay. I mean, I'm too slow. I am too slow. It's not that bad, but I am too slow. Well, that's definitely not right. Why is that so wrong for part 1? I mean, without getting leaderboard on this one today, but 5-4 going up. Is that right? Just going up. Why? Why? Six four 0 5 4 0 2 1 4. I guess this is 6 4 3. Oh, because I matched the initial thingy. I am dumb. No, it just keeps going. It's not a thing. Maybe? I don't know. No, that's not the thing, but 6 4 3 5 4 0 6 4 3. I don't get it. Why are you bugging out? Is something in 6 3? What's that 6 3? This is impossible to read, but that's what happens. Right, well, I mean 6 4 is a period, so why is it? I don't get it. Three is going left, so then 6 7 6 6 6 5 6 3. Then, but why? Is there something in the thing? Did I miss something? This is so annoying to debug. I mean, at this point, I'm not like pushing as hard because I know that I'm kind of done in terms of leaderboard, but it's still kind of I don't know. I feel like this should be roughly right. I did it the fancy way and I kind of got caught, but 6-3, 6-2, 6-1. So what does that mean? 6-8. I don't get it. I don't get what my bug is, or what my code is doing, honestly. And it's kind of unfortunate because I'm kind of sad. I don't know if I had a real shot, but definitely not anymore. Okay, so why is that? So it goes it goes 6-4, but 6-3. What is 6-3? Do I write anything in M by accident? Is that why? I mean, this. This is terrible. Five, 4. Which one is this? I think this one is 6-3, so I think one of these are actually right and I was debugging the wrong one. But 6-9 doesn't make sense, right? Do I not? Oh, I'm dumb. I didn't reset it for return true. Larry! I mean, it's gonna print too much, but I'm too lazy. Maybe I could. Okay, fine. Maybe I should. Larry! I actually was thinking about it and I still print too much. I was actually thinking about this when I was writing it, but then I just kind of forgot. And then I forgot it for way too long. Did I mess up? Does this not terminate? Why does this not terminate? Or am I just printing too much? I may be returning too much. Still printing too much. I thought RNC is 10,000. 10,000 squares, kind of maybe not that fast, but let me just open another shell so that it can run while I don't know. Is it day 5? Nope, it's day 6. Maybe I needed something smarter. I don't know. I'm just curious what the dimensions are. 130 by 130, 1729. 600, but that was a very silly mistake on my part though. I just wasn't I knew. Okay, let's see if we can upsolve this. This was brute force. I feel so silly on that one. And what is the timing on this? I feel silly because I was thinking about this, but I just kind of that is a silly mistake, Larry. I don't know if I've gotten the leaderboard, but it would be nice to kind of stay at the top, whatever. But that happens, right? Over 25 days, that's going to happen. It's just that you hope that your good parts of days or whatever will carry you through. But you know, these days there are no points, no point and no points. Oh well. I'm just curious what the timing is. The printing here no longer matters that much. 32 seconds, so we probably can optimize. Can we optimize? Let's see. I mean, the thing is, note is that the only thing that, so one optimization that you can think about, right, is that you only want to place a thing on your path, right? So that means that if we kind of roll it, so we can optimize by just rolling it once. How do I want to write that though? All right, I mean, right now the code is a mess. We're gonna make it slightly more messy in a kind of a TDD kind of way. But yeah, so okay, so maybe it's changed from buffer. So we'll try and make it faster. This takes 30 seconds or so. The reason is because it's R times C times this thing, which should be R times C at most. So yeah, so which is what's that, 130? I think I saw. Oh yeah, I think yeah, 130 squared or 130 to the fourth, which is a little bit high, right? So the way that you think about it is that you would only ever put an obstacle on the path. So we can write that out by simulating what the path is, right? So yeah, so maybe we have a thing called get path. I don't know, it doesn't really matter that much. And here we'll just copy and paste for now. We probably can make this cleaner, but I also do not care for this moment. We care about correctness, and we can optimize it later on. I don't think we need this. I don't think we need this. I think we just need. I think actually this technically already. Ooh, this already. Does it for me, the debugging thing, because we don't ever need this. Scene, you won't even need this really. So then here we just return array for the path that we took, right? And so here maybe we can path is equal to get path, and then we can print array just to kind of as a, this is a, you know, just as a, just as a test. AXAY. Oh, I think I have a. Wait, do I? What is it complaining about? 87. Oh yeah, of course we don't need that anymore for obvious reasons. Okay. Need to declare this on before. Okay. This is path now, Larry. Okay, so this is the. I want to say this. Oh yeah, this is for, not for. I wanted the only one for the testing one, but yeah. So this is the path that we quote unquote care about. So then now we can say for node in path. So then now instead of this thing, you can say for xy in path. I think technically there's a dimension thing, right? It's something like this. Then you can do this, right? Yeah, okay, well, I mean, it's faster, but wrong. Actually, I don't know if it's actually faster. It's still wrong, though, so that's not fortunate. Wonder why that is. I think it's because it counts the initial one, so I think that's why it's wrong. But maybe not, maybe, Yeah, maybe you don't want to put it into the, Like, we'll just skip the first entry, which is the starting XY, because I think that maybe leads to clunky things. But it's still wrong, 7 actually, or 7 instead of 6. Huh. I mean, maybe that my implementation is poor, honestly. No, it should be, I think it should be right. I mean, it doesn't make sense that this would be higher unless we double count something. So we probably overcounted something. Because the path, oh yeah, the path have overlays, so we probably just double counted stuff. So maybe you can just done something like very hacky, lazy, right? And then now instead of count, we do length of s. I think that actually makes more sense. Yeah, so now you have 6 on the test, and it still takes a while though. So let's see how fast. I mean, in the worst case, it's going to be the same, right? But it is 4 times faster. Now we cut it down to 7 seconds, which is way more reasonable. Can we make an additional optimization other than maybe using PyPy or something like this? I don't know. Honestly, I'm not sure. I think there is some, like, you could probably keep track of things in a way such that you know exactly where to add stuff. But I think that is a very complicated thing to do. But or like complicated but not impossible, right? And what I mean by that is that let's say you draw a line, and the case that so initially my thing was that if you went to a path that you've always seen, then actually yeah, you could create a walk somewhere to go into the loop. Actually, I don't even know if that's true, but I think there is some truth to it because of the way it is constructed. Because you always rotate, so therefore, if you visit the same place, then you always kind of like, because it always loops like in a counterclockwise kind of thing, right? But then the case that we missed is that you can loop, but then you have like almost like a P-shaped thing. So you go down and then you kind of want to loop back up. Maybe I'll use the. Let me show my personal time for a second. That was a rough one, but that was silly debugging though. So I don't know. It is what it is sometimes. I mean, you know, like you can't do it fast in all of them, I suppose, which is fine. But yeah. Oh wait. Yeah, what I mean is that I think there is. Where's my drawing thing? I'm like holding the pen, but not the pad, and I was like, why am I not drawing? But yeah. So the case that is tricky and pretending that these are straight lines is that if you do something like this, if you're here, you want to add a walk here so that you go back up to here. But that's not that hard, right? Because you know that for every column, like for every space that you visited, you can. You know that there's something north of all these cells or something. So you just have to pre-process these in a way if you really want to, such that everything in this column, everything in this. So basically, what you want to do, kind of, right, is that if you're here and you're going up, that means that everything to the south of this, if you're going left, you can put a walk here, dot, right? And then, so it's not quite the perfect way of implementing it, but I think visualization-wise, it makes sense. That means that if, and only if, that if you go here, then putting a walk here would make you loop, right? So that means that having this cell, you could pre-process this so that you kind of, yeah, you could pre-process all the cells on the south of this, and you can do this with like if you really want to get complicated but lazy, like I would be, like you could store that in a segment tree or something like this, or maybe even yeah, or I mean you can also do it the other way, right? Of for every cell you hit, you go, okay, is there any cell going upwards to the north of here, and if you pre-process this somewhere, and then you can maybe do some prefix something actually, right? Because here, then you prefix sum, it's less high machinery, but still workable, right? Is that then now you just in a way your prefix sum query would just be this region, or I guess technically actually this region, whether there is any cell that we've been to that is going up, and if there is, then putting a walk here would go us there. So you can do with that kind of math, you can do this in linear time actually, right? And by linear time I mean R times C is the linear time. I'm not going to implement this because I'm too tired. This is too late in the day for me, but yeah, but I think if you do it that way, then you could do it in linear time, R times C time, and R times C space with prefix sum. Actually, can you do it with prefix sum that way? Maybe not, because I guess that's a static prefix sum. Though I mean, you can actually, I guess you can actually also run it twice, so then it becomes a static prefix sum. So I think in that case it'll be r times c time and r times c space, which is linear time, linear space, right? Because that is the size of the input. Yeah, so I think that would be cool. If you run it twice, you get the entire path, you pre-process everything, and then loop it again to see where you would put a walk that gives you a loop. And that's pretty much it, right? So yeah, not gonna implement it like I said because I'm lazy today. But yeah, I'll go over the code run. I mean, I don't know that I actually went over the code, technically speaking. So I'm gonna go over the code real quickly. Oops, it's still up here. How do I? Technology. How does this work? Okay. So part one, I don't think part one requires too much explanation. I think it's all about implementation. I convert this to a grid. I have this library. It's to infinity grid, but it's not a real, like, it's not something too complicated. It's just so that you don't think I'm doing some crazy things. I think it's in helper, or maybe it's in grid. But like my infinity grid, I just put everything in a oh, you can't see. Well, I don't know. Well, okay, let me just paste on the left side, right? So the infinity grid, all that code is this code, which is a collection of default dig to default dig, and then I just walk through the grid to so basically it's just a map of a map instead. I don't know. I don't think that was useful for this one, but I'm like playing around with that idea in my head in general from some other problems that I've seen. So that's kind of the idea, but it doesn't add or subtract anything. In fact, in this one it's a little bit trickier because I still have to get the R and the C to get the rectangular bound. But yeah, and then here we find the initial square, get the direction. This is up, down, left, right in some order. No, sorry. This one is in a specific order, which is up, right, down, left. I actually have this written out, but I had to maybe relook at it to make sure that it's in the right order. So I think that's the reason why I kind of had to write it out. And then everything else is just, the cells that we've seen, and then we just kind of walk the thing. And that's part one. Part two is a bit of copy and paste. My initial way of doing it, as you might have seen. So it's basically brute force, right? Without overlapping my explanation for part one, I have I set this cell to to a walk or whatever it's called, and then I just want to check to see if we've been to the same thing, or been to an infinite loop which has x, y, and the direction as a triplet. And if you can, then we return true. And I forgot this part. Oh, I forgot to revert it before returning. This is why in real production programming, don't mutate state if you can help it. I knew that I was breaking that rule, and when you break a rule like that, you're like, remember to fix it, and I just forgot to fix it, and this is how you bite you. But of course, it's only admin of code, so it's fine. But in production, these are things that you try to avoid unless you really, really know what you're doing. And clearly, I do not. So I try not to do things that I don't know what I'm doing. But in any case, yeah. So as a result, initially we try every walk. So that's going to be R times C times R times C, which is quadratic in the size of the input. And then we made an optimization that made it about 4 times faster, but technically in the worst case, it'll be the same, because the worst case is, I guess, a path that goes for every walk, which is technically not also possible because you need walks to turn, but roughly speaking is the worst case. It's just getting the path and then checking all of these. And then you can optimize this to R times C time and space with what we discussed earlier, which I'm not going to repeat. And yeah, that's pretty much it. That's all I have for this one. My code is kind of long and ugly, and in this particular part, it has some copy and paste elements for get path and what I call the good function. So yeah, let me just show the top of the part 2 real quick. So all this is copy and paste. This is just get path, which is mostly copy and paste, and I just kind of get the path of the default path. The good function, as I already mentioned, we just kind of have a cell that we want to brute force a rock on, and then we just kind of do this. But yeah, that's pretty much all I have. Let me know what you think. Thanks for watching, and yeah, maybe tomorrow's the day. I feel like I've been saying that all week or all month, but oh well. Anyway, yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Hope to see you tomorrow. Bye bye.